Hello. So I'm super late with my experiment. I apologize, but I still wanted to give it a go to see how the ice formation works. So today we're in the lab and we're making instant ice based on what we've learned in regard to physical and chemical properties of matter, as well as pure substances and mixtures. Note that we will be using new 16.9-ounce bottles of purified water to do this, which means the freezing point should be higher than if the water was not purified. Each bottle sat in the freezer for about an hour and a half to 2 hours, I would say. If this is done correctly, we will identify supercooling, which is when the liquid water has not changed phases and is still not solid. However, has still been cooled long enough that it is below freezing temperature, which we are aware is 0 degrees Celsius. There are no points of nucleation, which is why the water hasn't completely frozen. And these are our materials we will use. So for this experiment, for the supercooling, what I wanted to happen was a flash freeze. What was supposed to happen was the water flash freezing, meaning you could physically see it turn into ice through the bottle, which would have nucleated the ice formation. And that would have been considered a physical disturbance of a supercooled sample. However, I don't think the ice was frozen enough, even though you can see the ice more at the top of the bottle. But even pushing down on it, I'm not physically seeing the change like which I have before. Like you could squeeze on it and it would completely show the formation. So I think that if I repeated this, I would freeze the waters even longer, maybe even 30 minutes longer would have been a different temperature to the point where you could physically see the change. Now we will experiment with the super cold water and what happens when poured onto solid ice. We want the water to instantly crystallize, which starts with the steps of supercooling, then nucleation. So let's see what happens. See, and although the water is cold and you can see the ice in the bottle, I don't think it's cold enough to show the crystallization. See how the liquid is just pouring into the bowl. So again, I would freeze the waters even longer. I thought that it was going to be too long, but clearly not long enough. So repeat, I would freeze the waters maybe 30 minutes longer. Now we will use our super cooled water and try seeding it with an ice cube, which ultimately means ice nucleation again. We are using this glass to pour the purified water, and we definitely made sure that the glass was extra clean, so no impurities from previous use from my family, which could obviously impact the nucleation. So we're pouring the water. You can hear the ice in the bottle. And I'm going to take one of our pieces of ice and hold it at the top of the glass. Although I'm sure the ice is obviously making the liquid water colder as far as temperature, I believe this entire experiment proves that the importance of your initial water being used, your materials being cold enough and freezing temperature. Otherwise, the ice formation is not happening as expected, as your hypothesis. So again, to experiment with these, again, I would definitely have cooled the water even longer, so we could see the nucleation happening. It's not happening as expected because I don't believe the water is as cold as it appears to be, even though you can see the ice within each powder. So again, I would probably freeze it for maybe another half an hour, maybe to even an hour, to really see the difference. Thank you.